This is segment 7 of the Module 2 lecture, and this is to talk about other graphs to display continuous data. Let me briefly go back to the histogram. And one of the problems with the histogram is that because we're putting bins, the values that go into those bins, we really don't know what values there are there. For example, in this lower bin, we say, well, there are a certain number of loans or amounts of loans that are between $4,000 and $14,000, but we don't know exactly what values of what are the exact amounts of those loans that fall in this category. And that could sometimes, from the practical point of view, is a disadvantage of using the histogram. So there are two other tools where the actual data is shown, and they try to mimic the histogram. The first one is the stem and leaf diagram. It's not used very often, but most statistical software packages offer this option. The dot plot is a more frequently used type of graph where you can see the values in the data, not exactly, but close to see the different values in the data. Whereas in the stem and leaf, you can see the exact values that were recorded. All right, let's look at the stem and leaf diagram. As I said, it tries to mimic the histogram, so it's equivalent to the histogram. The great advantage of the stem and leaf is that it displays the actual observation values. And another thing to remember is that the values are divided into what is called a stem and a leaf value. So here's an example. So here's data values, 21, 25, 225 values, 26, 27, 28, 30, 236 values, and 45. Now you see that this is increasing in tenths. So the stem values could be in tenths, or tens rather. So you could put 2, 3, and 4, and then you say, okay, well, the first value that in the category of the 10 numbers in 20, so you could see the first value is 21, so you put a 1. And then the next two values is 25, so you put 2 5s, and 26 is 6 here for the 27, a 7 here, and an 8 here. And the way you read it is, okay, 2 1, that must be a 21. 2 5, that must be a 25, or like what I'm showing in this diagram, that 2 6 corresponds to 26. So now the next set of values get assigned to the category for the 30ths, and so you have 0, 6, and 6. So now you know there is a value of 30 and two values of 36, and there is only one value in the 10 and the 40 range, and that is 45. So that's how the stem and leaf works. So you find how you can divide these numbers into a stem and a leaf. And again, this is a very simple example that you can see it very quickly how to divide the data. Here's another example. This is an example we looked at, well, similar. We looked at this. Here's the scores in an exam of 20 different students. Now, in this case, is the actual score that they obtain on an exam. And so you can see by scanning the data that the lowest score is 34 and the larger score is 100. And so, since you're spanning numbers from 30 to 100, so it kind of makes sense to select the stems as tens. So in the first stem value, you have 30, and then you scan the grades, and you see that there is a 34 grade, a 35, and a 37 grade, somewhere in here, right here. And then you look in the 40s. Well, what values you get in the 40s? You get a 45 and a 47. Also, you look at the 50s, and you see what values you obtain in that range from 50 to be less than 60, And then you can see that you have a score of 51, 55, 57, and 58. Also, it is customary to put a little legend where you specify what is the value of the leaf. The leaf in this case is 1 unit. And so you can now see, now that you create a stem and leaf, you can see the distribution of scores in this exam. And you can see that if 6 is a passing score, well, then you can see that, well, you can count how many. There's 2, 4, 5, 8, 10, 11 scores were a passing score, and then you have 4, 6, 9 scores in the failing category. You also see that the scores are not too bad. There is 100, 1 perfect score. There were 2 in the 90s, 3 in the 80s, and 1 in the 70s. So again, by looking at this, you can talk about how the distribution of scores is, and what you think it tells you about this class. All right, so this is the stem and leaf. Again, I'm not going to dwell too much on this. I assigned 1 homework problem on this, but this is not used very often, but you need to be aware that this exists. The next graph is the dot plot. Again, it's equivalent to the histogram. In here, the way we do it, we draw the axis with a scale, and then for each data value, we put a dot above the axis, as shown here. Now, if we have 2 values that are identical or very close to each other, what we do, we place a dot on top of the other dot. If we were to have thousands of values, then a dot may represent not only a single observation, it may represent 20, 30, 40, 50 observations. So dot plots can be used when you have a lot of data. So in this example, we have the data values of 100, 2 of 100, 99, 103, and 103.1. So we have 200 values. So on 100, you see 2 dots. Then we have a 99 value, you see dot and 99. And 103 and 103.1 are very close to each other. And so they are just put as one on top of the other, because they're very, very close to each other. So that's the way you construct a dot plot. And for example, when I summarize the grades of an exam, I like to do it in a dot plot, because you can see the grades and you know that each dot represents a grade or a score in the exam or a quiz for the student, for each student. So you can see where your grade is and how you did relative to the other student in the class. So here's an example that comes where the scores are now reported on a dot plot. And now this is the same data that we use for the stem and leaf. So again, here you're looking at the frequency of the scores by groups of tenths. And in here, you're seeing the actual data. And you very quickly see how the data is distributed. So as I mentioned a minute ago, I like to show the results of an exam with a dot plot. So if your instructor provides this dot plot to summarize the scores on an exam that you just took, what can you say about this exam? Well, if you look at this, it's like a big group over here and a big group over here. So, well, it seems like a good amount of people didn't do so well in the exam. Some passed it, but their score was not very high. Very few, less number of students had better grades, 72 and above. And then only 3 score above 90. So now you can see this, and you can see if you got a particular score, let's say you got a 72, then you can say where you are with respect to the other scores. I remember with my daughters, when my daughters were in college, I will ask them, what do you do? How do you do in your exam? I said, well, I got a 72, but only if this many had scores higher than me and this many have scores lower than me. So they tried to make me feel better about their exam. because I was always asking them how they did on their exams. And I always try to exercise this idea of dot plots and frequency diagram to see how you did with respect to the other students in the class. So again, a dot plot is used more often than the stem and leaf. But again, our workhorse in the class is going to be the histogram. All right, so with this, we complete the Module 2 assignment. So now you can go to Wiley Plus to look at the Module 2 assignments. There are 3 parts. And I'm sorry that it looks so many parts, but the way that Wiley Plus is structured, it gives you problems per section of the book. So what I do, I create a section, an assignment for each of the sections of the book. And I try to put 2-3 questions. I know in some of the bigger modules, I have put 5 or 6 questions. But hopefully you can solve them very quickly. Many of them are multiple choice. A few ask you to do other things. But again, if you have any problems, please contact me or come to the office hours. And if you cannot come to the office hours, well, then send me an email. We can schedule a Zoom meeting and we can talk to each other, and I'll be glad to help. Unfortunately, at this time, I have a relatively flexible schedule so that I can meet you almost at any time. Not all the time, but almost any time. All right, so with this, we complete Module 2, and at this point, you should be comfortable creating a frequency distribution using data from a qualitative or a quantitative variable. You should be able to select the appropriate graph to display the frequency distribution for either a qualitative or a quantitative variable. You should also be able to explain in understandable terms what a frequency distribution represents, and explain in understandable terms what a graphical display of a frequency distribution, and be able to draw practical conclusions. Again, with this, we're done with Module 2 lecture. If you have any questions, please let me know. I'll be very happy to help you.